Alright, so today we're going to do 7.1 part 2. Part 2. So we just have example 4 left to do. We're doing the same thing as yesterday, but now it's just in a word problem. So the time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. So, key word here is that it varies inversely. If it's inverse variation, what's the formula we're going to use?
X over y.
Y is equal to A over X. So this is our formula from yesterday. But here in this question, it gives us time t and number of volunteers n. So that is actually our y and our x. So we can just replace y and x with t and n. So t is equal to a over n. If you want to leave it as x and y, totally fine. And we want to plug in the numbers that it gives us. So it takes a group of 10 volunteers 8 hours to build the playground. So we're going to plug in 10 for n, 8 for t, and then we need to solve for a. So we have 8 is equal to a over 10. How do we solve for a? Multiply 10 on both sides. So we have 80 is equal to a. So our equation is t is equal to 80 over n. And it asks us to make a table showing the times it would take to build the playground. So just like the tables we had in our notes yesterday, we're going to do the same thing. But we have n and t, just instead of x and y. So it gives us the number of volunteers. So we have 15, 20, 25, and 30. So we just need to plug each one of these values into our equation here. So let's plug in 15. We have t is equal to 80 over 15. What do we get for t? So 15 goes into 85 times with how many left over? 5. So 5 out of 15. Which 5 out of 15 would simplify to what? 1/3. So 5 and 1/3 hours. I guess we could say 5.33 hours. Or 5.3. Alright, next we want to plug in 20. So we have time is equal to 80 divided by 20. What do we get? 4. Next we plug in 25. So t is equal to 80 over 25. What do we get? 3 and 1/3? You can put it in the calculator. 3.2. And then lastly, we want to plug in 30. So t is equal to 80 divided by 30. What do we get? 2.66. So there's our table. So all we do is need to come up with a equation and then just plug each number in. Yes, Casey?
If it's 2.6615, would you round it to 2.67 and just leave it at 2.66?
You can round it to 2.67. Alright, the next question asks, what happens to the time it takes to build the playground as the number of volunteers increases? So we see that our number of volunteers is going up. What happens to the time as the number of volunteers goes up? It decreases. Time decreases. So when something has inverse variation, varies inversely, as one thing goes up, the other one goes down. So that's just a definition of inverse variation. So since the volunteers is increasing and it varies inversely, time decreases. So we could tell that it's going to be decreasing without even doing all that math, just because it told us that it varies inversely. So in example 4, the last example we just did, it takes a group of 10 volunteers 12 hours to build the playground. How long would it take a group of 15 volunteers? So we're going to use that same equation, but we have a different value for A because it's a different set of volunteers and hours that it has. So our equation is T is equal to A over N. We just want to plug in 10 and 12 and figure out what A is. So we have 12 is equal to A over 10. How do we solve for A? Multiply 10 on both sides. So we get A is equal to what? 120. So we have T is equal to 120 over N. How can we find out how long it takes a group of 15 volunteers? Plug in 15 for N. Awesome. So 120 divided by 15. Awesome. 8 what?
8 hours.
Perfect. 8 hours.
Does it matter?
Because N is the number of volunteers. That's what N stands for. T is time. So that's how we know 12 went here and number of volunteers went here.
Okay, but if the function is different and it's not volunteer and time,